Hi, I will show you how to interface this with MIcrocontroller. Uh, in this tutorial, I'm going to use MIcrocontroller MIcrocontroller. You can see here. Um, it's a perfect microcontroller for its communications. Um, this microcontroller has its own internal PLL circuit which converts 4 MHz clock to 96 MHz clock. It's very important. We need this microcontroller. Now I'm going to make this circuit. We need 22 picofarad capacitor to run this microcontroller. On, ground. It's the There's another important part. We need 220 nanofarad capacitor to connect with the USB port here. So here's the capacitor. Let's connect with it. And see how it's connected. I'm going to use USB connector B type here. Here, the D plus pin should be connected with the D plus here, 6 number pin, and D minus with D minus. That's all the circuit. This is all of the circuit. Now we need a source hex file for this microcontroller. So we have to create a new project in Mac C. I'll make that. Here. My USB test project. I'm using MIcrocontroller microcontroller, and the crystal should be 12 MHz. Next, include all defaults. We need to edit something on project properties. So click on that and then finish it. As the most important part, MIcrocontroller has its own internal PLL circuit to convert 4 MHz clock to 96 clock, 96 MHz clock. We used 12 MHz crystal, so we need to divide it by 3 because we need 4 MHz clock that will be converted with PLL circuit. So you can see that divided by 3, 12 MHz oscillator input. Primary oscillator should be that. Our 96 MHz PLL signal, the USB source comes from the 96 MHz PLL, should be divided by 2. And here we select it. I've selected it. And the oscillator selection should be here. We must have to enable the voltage regulator to make the successful connections. So that's okay. I'll write source code. Signed factor with receive data, receive data 64. Here we have defined absolute 0x50. It's the location of USB RAM, because we're going to save this. We're going to save the received data on USB RAM and send data variable should be on that way. Send data, and this we'll need an integer variable, integer i0. We need a USB interrupt function, so interrupt, void interrupt, USB interrupt function. This function initializes your USB and that means your HID or USB will enable with the received data and send data. Need a while loop. It's an infinite loop. While not wait. We're going to send the same data we have received. Will receive. So x is 0. We're going to write data what will be received. Then a function to send data. Right. Send data here, and it should be 64. There's our source code. We need a descriptor file with our source code. It's a very important file. Actually, the descriptor file will get your computer to understand about your device informations like as vendor ID, product ID, manufacturer ID, etc. You can click here, and there is descriptor. It's vendor ID and product ID, vendor name, product name. The bus bar is enabled. It's the very important. Is make sure that your microcontroller can get its power from your computer. If you disable it, you can't get it. Actually, it's give the permission for your microcontroller to take far from computer. I'll save it. Let's save here. I have to add it with the source. So add file to project. Extract here. Run it. My.hex. Here. My.hex. Okay. If you like to select the USB connection from Proteus, we need to install the virtual USB. For Proteus, here, virtual USB, we need to install it. I already have installed it, so I'm now going to modify it. Okay, finish it, then just run the project. To show the communications, I have to use, you can see that my device, and there is a USB HID terminal. We can send data from here, and hi, it's me. Send it and reset it. Welcome. Welcome. So in this way, we can make user connection with our microcontroller. So thank you.